Welcome to Shiksharthi, and today's our topic is on relations and functions under modern maths. This will be a continuation video on my last video of sets, relations and functions. In my previous video we discussed about sets. What is sets, what are the properties of sets, how do we present sets, and all that we did. Now today we'll be talking about relations first, followed by functions. So let's start about relations. Now before we know about relations, we need to know what is meant by Cartesian product of two sets. Cartesian product of two sets means, suppose if I have a set A here and a set B here with elements 1 and 2, and here we have A, B and C, then I'll be mapping 1 with A, 1 with B, 1 with C. Similarly, I'll be also mapping 2 with A, 2 with B and 2 with C, and I'll write them like in order pairs, like 1 comma A, 1 comma B, 1 comma C, followed by 2 comma A, 2 comma B and 2 comma C. So what I did, friends, all the possible pairs I have written over here, that is called Cartesian product. So we can represent this as A cross B as a Cartesian product. So you can see how many order pairs I got here. Order pairs I got 1 comma A, 1 comma B, 1 comma C, 2 comma A, 2 comma B, 2 comma C. Total 6 order pairs. And if you observe, here there are 2 elements with us. Here we have 3 elements. When I multiply them, or when I take a Cartesian product of 2 sets, I'll get total 6 order pairs. Now second thing which we need to always observe, the mapping is done from A to B, or here we are doing A cross B. So when I do A cross B, the elements here, if you see, this is called ordinates in the order pair. The first ordinate is from A and the second ordinate will be from B. Similarly, if I do B cross A, imagine if I do B cross A, then the first order or first ordinate will be from B and second by A. So I will be writing this as A comma 1, A comma 2, B comma 1, B comma 2, C comma 1 and C comma 2 as order pairs. So total number of order pairs, again I get 6, but the order pair which I got here will not be same as the order pair which I get here. Number of order pairs are same. Here I got 6, here also I'll get 6, but the order is different. Here 1 comma A and here it is A comma 1. The first ordinate and second ordinate will change. So you can say some particular points about it. I have taken a similar example here, 1, 2, 3 with A, B, C. When I say A, P cross Q, or Cartesian product between P and Q, P is mapping to Q, all the first ordinates of the order pairs will be from P and second ordinates will be from Q. So when I say P into Q, first ordinate will be from P and second ordinate will be from Q. So that's an order. And when I say Q into P, it's first ordinate from Q and second from P. So in that way we got this. Okay. So total number of order pairs, how many I'll get? If I have 2 elements here, if I have 3 elements here, total number of order pairs will be 6. Here if you observe, here I have 3 elements in P, 3 elements in Q. Total number of order pairs will be 3 into 3, 9. And if you count here 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4, 5, 6, 7, 8, 9. Here also I got 9. So few points which I wish to say. Suppose P has got X elements, Q has got Y elements. When I multiply P into Q, or when I take a Cartesian product of P and Q, I'll get total X into Y number of order pairs. X order pair, X elements, Y elements, product will have X into Y number of order pairs. Like 3 into 3 here is 9. Here 2 into 3 is equal to 6. 6 order pairs I'll get it possibly. Second one, as I told you, AB is not same as B into A. A into B is not same as B into A, because the order of mapping will change. Here the first element or the first coordinate will be from A, second will be from B. Here first will be from B, second will be from A. So order is reversed here, reversed order. So here P into Q will not be equal to Q into P. This point also is important. But number of pairs which I get will be equal. Whether I do A into B or B into A, I got 6 order pairs in both the cases. So that is what is called as Cartesian product of two sets. Now let us proceed here. Let us proceed to next point here. Now, what is important to understand, my friend, here if I map this in a graph, I'll take a graph here to make you understand what exactly it looks like and what is the other type of presentation we have here. Let me take this as P, let me take this as Q, and here the vertical lines represents P, horizontal lines represents Q. And what was the numbers I have taken here? I have taken this as 1, 2, 3, this as A, B, C and so on, let us take. So if you observe in Q set, we had only A and B. So 1 to A, 1 to B, 1 to A, 1 to B, 2 to A, 2 to B, 3 to A, 3 to B. So no total number of order pairs will be like 1 to A, 1 to A, then 1 to B, then followed by 2 to A and 2 to B, and followed by 3 to A and 3 to B. Here we are getting one useful point and very important point. The first ordinate of an order pair represents like x-axis. 1, 2, 3. The first ordinate of this order pair represents x-axis, and the second ordinate, that is AB represents y-axis. So whenever you write an order pair, it will be in the form of x comma y, which we all know it. X represents x-axis, y represents y-axis. So all the first order will be of x-axis, second will be of y-axis. This is per P into Q wala graph. Now here if I take the same thing as Q into P, a similar one we get. Vertically we get A, B, C, and horizontally we get 1, 2, 3. Here I get 1, 2, 3. So when I do Q into P, it is A comma 1, A comma 2, B comma 1, B comma 2, B comma 3. Here A comma 3 also you get. So here the order pairs will be 1 comma, or sorry, I'm sorry. Here it will be the order pair as I get as A comma 1, A comma 2, A comma 3, and then followed by B comma 1, B comma 2 and B comma 3. So here Cartesian product can be presented in the form of a graph like this. This is a graph of Q into P, and that is a graph of P into Q. So see here, the x-axis I got A and B, y-axis I got as 1, 2, 3. Here x-axis is 1, 2, 3 and y-axis as A, B, I got it. So that's a difference between P into Q and Q into P. I think you all now must agree with me that P into Q is not equal to Q into P. But number of order pairs are 6, number of order pairs are 6. Number of order pairs which I get after Cartesian product will be same. Now what is the significance of this Cartesian product? The significance of Cartesian product is to understand the definition of relation. If I take few order pairs out of this, that forms a relation. So what is a relation, my friend? Here you can see I gave a definition here for relation. It is a subset of P into Q or Q into P is called as relation. So what is relation? If I select a few order pairs, not all, then it forms a relation. So relation is a subset of all the possible order pairs. And how do I get all the possible order pairs? By doing Cartesian product of two sets. Okay, Cartesian product will give you maximum number of order pairs, of which few order pairs can form like a relation. So relation is nothing but subset of order pairs which I get out of Cartesian product of two sets. Okay, that's an important definition. Now let us move on to next part here, which is a domain and range, which is very important words from here onwards to everyone. Now what is domain and range? Keeping the same thing, listen all of you very carefully. What is domain and range? In this, my friend, x-axis always represents domain. This numbers, the first coordinate will always represents domain values, and the second coordinate always represents range. So what is domain and range? I am trying to make it very simple. I am not going by definition here. See here, the easiest way to understand. In this case, 1, 2, 3 represents the value of domain set. And how do I represent this? This one, this domain set here will be 1, 2 and 3, and here the range set, whatever we have as a range set, that will be A and B, and we'll be doing a mapping on this. So all these first set numbers, how do we map, and what will be the outcome? 1, A, 1, B, 2, A, 2, B, 3, A, 3, B. So all the first values will represent domain, all the second values represents range. So it's very, very simple, domain and range. So the two definitions here. Now you can see a clear definition of domain and range, what it says. In the product of or Cartesian product of P and Q, all the first coordinates represents domain of the relation, and all the second coordinates, you see the definition here, second coordinates, the first coordinates represents domain and the second coordinates represents the range of the relation. So first coordinate represents domain of the relation R, second represents range of the relation of R. So we all understand what is domain and range now. Let us move on to another one. Next definition here. Inverse of a relation. What is inverse of a relation, friends? Inverse of a relation means, suppose I form a relation here first. I'll take an example. I have a domain, I have a range, and between them I am taking a relation. Say 1, 2 and 3, A and B. I formed a relation taking few order pairs of 1, A, 2, B and 3, A again. I got a relation here. Now this is domain, range kind of a thing. If I write the same thing reversing every order pair, that is A, 1 and B, 2, here we get 3, or A, 3 as order pairs. You see, every order pair is reversed. That means a domain becomes range, range becomes domain, then we consider that as reverse of a relationship. So first, what is a relationship? You have between domain to range. Now when you take reverse of this, it will be is equals to range to domain kind of a stuff. Okay, all of you? So order pairs will reverse, mapping will be from 1 to A, 2 to B, 3 to A, will be reversed as A to 1, B to 2, B to 3, like that. So this will become domain and this will become range. That's a difference between the two. So inverse of a relation is also we have seen. Now let us move on to next definition, which will be very, very important, and from here the next few minutes will be very, very crucial for you to understand what is functions. While understanding functions, friends, the very important task is to understand the definition and the properties of functions. Very, very important points. Every time, whenever I am using a word function, all the properties of function must be applicable, must be satisfying. Otherwise, we cannot apply, because there are types of functions also available. When I say one-to-one function, first type, second on-to function, bijection function. So whenever I am saying function, the properties on functions, I made a note here of the properties. You can also pause the video and take a note of all these properties. Whenever I say it's a function, make sure that all these points satisfy. So I'll be taking a little of extra time here to make you understand what is the definition of a function. Very, very important. Okay. A relation F. Here the relation's name is F. F represents function. Please take it simple. Okay. Which associate to each element of set A exactly one element of set B is called function. Now this itself, this point itself is very, very important. It says each element of set P. That means every element of set P must be associated with one element, only one element of set B. Only one element of set B. Every element of set P must be associated with exactly one element of set B. Then the things are called as the relation here will be called as a function. So to understand this, my friend, I'll give a lot of examples. Okay. So one by one, let us take. First, we need to decide whether it is called a function or not. So this is on a regular basis called as domain. And here I use another word called codomain. I'll explain in few minutes what is meant by codomain. Earlier I was writing a range over here, right? I was writing a range. So I'll tell you what exactly will be the difference between codomain and range. Have a little of time it will take, but it will be very clear for all of us. Okay. Now, suppose I am trying to find a relation here. I am trying to get a relation here which can be called as function. Can be called as function, and every function will have a name. Like here I am giving f as a name, and let me call this is domain set. Okay, domain set, and that is called codomain set. Here we have A and B as two sets. So here I take set as 1, 2, 3, and here A, B as only two elements over this. Now what is the definition saying? I'm sorry, let me take this as P, because in the definition it is given as P and this is given as Q. So let us, to avoid confusion, I'll take it as P and Q. Now what the definition says? Definition says that if I have mapping like this, try to understand my point here. There are 2 points which are very crucial. I'll break that 2 points. It seems to be one definition, but I'll break it into 2 points. It says every element of set P. Is every element mapped with Q? Elements of Q? Here 3 is not mapped. 3 has no value. 3 has no image. The word image, I'll explain what is it. Here 1 has an image which is A. 2 has an image which is B. 3 don't have an image. Here 3 is not associated with any element. Then this is not a function. Instead of understanding what is a function, it is always better to understand what is not a function is. So to learn functions, first learn what is not a function. Okay. Now taking another example very quickly here. If I take 1, 2, 3, taking another example, this is set P and we have a set Q with A and B. 1 is associated with A, 2 is associated with B, 3 is associated with A. Now what it is saying, the definition says that every element of P must be associated with elements of Q, and exactly one element also. It should associate it with exactly one element. A similar picture I'll take it here to make you understand. Say this is P, this is Q with elements 1, 2 and 3 with elements A and B. Say 1 is mapping with A and B, 2 is mapping with A, 3 is mapping with B, for example. Now here how many images 1 has got? Definition says it should associate it with exactly one element of Q. One element of Q. But here 1 is associated with 2 elements of Q. Instead of one element, it is associating with 2 elements. Again, this is not a function. It should associate with exactly 1. Now here if you see, 1 have how many images? Only 1. 2 have how many images? Only 1. 3 have how many images? Only 1. So here multiple elements can have the same image, but if you look at it one point of view, see the association of 1. 1 is associated with only A. It has got only one image. Important is it has got only one image. 2 have only one image, that is B. 2 has only one image. And 3 also have exactly one image. Important is what is function now? I'll define here. Here all the elements do not have association. No function, it's not a function. Here you have multiple images, multiple associations, not a function. So now see the definition. All the elements are associated? Yes. Second, every element have exactly one image? Yes again. So what is important? Every element should be associated and every element should associate with exactly one element. That is what is called as function. And this, if I call the function as f, then f is mapping from P to Q. The words I'll tell you, this is mapping from, this word is mapping from. So function f is mapping from P to Q. Whenever I write like this, P represents domain, P represents domain and Q represents codomain here. Now you must be wondering what is meant by a codomain and what is meant by range. That we'll understand. But first let us understand one more quick example here. Okay. Suppose if I have a C also here in this case. Imagine if I have a C. Imagine I have a C here. Let us take this. Is this a function? Yes. What is the definition of function? Every element must be associated with Q, and that too with exactly one element. That too it should be associated with one element. Now here Q may have extra elements which have no pre-images. Q may have extra elements which have no pre-images. Here there is no association with C. None of the elements of P are associated with C, but still it's a valid function. I have to have all the associations with the element of P. The first set elements should be associated, not necessary with the second in the similar manner. Now what is the definition of codomain and range, my friend? Codomain, for example. If I take codomain, it's a second set with all the elements A, B and C. This is called codomain. And what is range in the same set? Please understand the difference here. Range is only A and B. Since C do not have any association, we consider C is not a part of codomain. What is range? Anything which have pre-images. The elements which have pre-images set is called as a range. So here let us now take a break on this. Till this point I want you to take a quick look on these points, and then we'll take next example on the next video. Okay, what is a range? Range is a subset of codomain. So you can see the first point, range is a subset of codomain. P into Q is a Cartesian product in which F function is a subset. It's a relation. Function is a relation. So relation is a subset of Cartesian product. We all know. So function is a subset or equal to Cartesian product. Second point. Third, every element of P has a one and only one image in Q. So here 1 have only image, 2 has only image, 3 has only image. How do we write this, my friends? How do we write? Function's name is f of 1 is A, f of 2 is associated with B, and f of 3 value is something like 1. Again, A is the value. So here for 1 image is A, for 2 image is B, for 3 A is the image. Now reverse is called pre-image. For A, pre-images are 1 and 3. For B, pre-image is 2, and for C there is no pre-image. So image and pre-images are the words. So third point says every element should have a unique image which is there. Next, 2 or more elements of P can have the same image. You can see A has 2 or more pre-images. So same point is discussed over here. Next, there may be elements in Q which do not have F images. See, C has no F image. It has got no pre-image. So such elements can be there in second set but not in the first set. If you have a first set without any image, then it is not a function at all. Okay. And the last part, number of functions to determine the formula will be here. It is called n to the power of m as a formula. How many functions can be formed with elements? I consider this has got m elements and this has got n elements. So answer in this case is n to the power of m, which is 2 to the power of 3 as elements. Okay, all of you? So that will give you number of functions here. So these are the this is the definition of functions. Very, very crucial point. Please make a note of these points which I gave you and the examples which I gave you. That will help you to understand what is functions. Keep practicing this. Till then, thank you.